In this example, we are dividing rational expressions. And so I have a fraction, a rational expression, divided by another rational expression. And so when we're dividing fractions, one thing to remember is that it's equivalent to multiplying by the reciprocal. So I don't want to think about this as x cubed plus x squared minus x minus 1 over, I'm going to write this in standard form, negative x squared plus 1, instead of being divided by x squared plus 5x plus 4 over x squared plus 3x minus 4. I want to change this to multiplication by multiplying by the reciprocal. So this is that first fraction times x squared plus 3x minus 4 over x squared plus 5x plus 4. Okay, so dividing by a fraction is the same as multiplying by its reciprocal. So I want to start out the problem by flipping the second fraction, writing its reciprocal, and changing the division into multiplication. So from there, I need to factor. This first numerator is 4 terms, so that means that we need to factor by grouping. So let's kind of start with that and not work with the whole expression yet. So if I have x cubed plus x squared minus x minus 1, and I need to factor by grouping, I want to think about that as 2 separate groups of 2 terms instead of one polynomial with 4 terms. And so my first 2 terms are x cubed plus x squared, and so those have a common factor of x squared. And if I factor out an x squared, x cubed divided by x squared is x, and x squared divided by x squared is 1. Negative x minus 1 just has a common factor of negative 1. Remember, when I'm factoring by grouping, if there isn't a common factor other than 1, I have to write the 1 because it kind of helps me see what the resulting factors are. So x squared times x plus 1 minus 1 times x plus 1, those 2 terms have a common factor of x plus 1. So that means this factor is 2x plus 1 times x squared minus 1. Because if I divide this whole term, x squared times x plus 1 by x plus 1, the x plus 1 is going to go away and I'm left with x squared. And if I divide this piece by x plus 1, the x plus 1 is going to reduce out, and I'm left with negative 1. So right now, my numerator is x plus 1 times x squared minus 1. But what I know is that x squared minus 1 is actually a difference of 2 squares. So this first x plus 1 is a factor, but then x squared minus 1 is equivalent to x plus 1 times x minus 1. So now that I have that numerator, I know that I can now start with the rest of the expression. So all of this was just that numerator. Okay, so that piece is now x plus 1 times x plus 1 times x minus 1 instead of x cubed plus x squared minus x minus 1. So let's rewrite that part of the fraction. So we've got x plus 1 times itself times x minus 1 over, if we look at the denominator, negative x squared plus 1 is the same as having negative x squared minus 1. So we want to factor out a negative so that we can factor the result. For now, let's look at the other ratio to figure out those factors. So looking at x squared plus 3x minus 4, we want 2 numbers that multiply to negative 4 and add to 3. So since it needs to make x squared, I know I'm going to have x times x. To make negative 4, I know that that's going to have to be plus 4 minus 1 because positive 4 minus 1 makes positive 3, and then their product is negative 4. Similarly, if I wanted to be 5, to add to 5, I'm still going to have an x plus 4, but this one's going to have an x plus 1 so that 4 plus 1 adds to 5. So looking at this, we can further factor our negative x squared minus 1. So I'm just going to kind of do that underneath so that I don't have to rewrite this again. So x squared minus 1, I know is a difference of 2 squares. So that's going to be x plus 1 times x minus 1. Okay, so just to save some space, I've refactored that underneath itself. So looking at this expression, I can see that the domain of this rational quotient is going to be all real values of x except for -1, +1, and -4. And then the last one, again, has a 0 of -1. So our domain is going to restrict values of -1 for the x plus 1 factors in our denominator, +1 for the x minus 1 factor in our denominator, and -4 for the x plus 4 factor in our denominator. So now, if we're looking at numerators and denominators and reducing, in our first fraction, we have an x plus 1 in the numerator, so I can divide that with an x plus 1 in the denominator. Similarly, I have an x minus 1 in the numerator and an x minus 1 in the denominator, so those divide out to become 1s as I reduce. Then if I look at the next set of fractions, I have an x plus 4 in the numerator and an x plus 4 in the denominator, so those are both going to reduce to 1. And then if I look across fractions, I can see that I have an x plus 1 and an x plus 1. So all that I have in my numerator is 1 times 1 times 1 times 1 times x minus 1. So that means my numerator is going to be x minus 1. And then notice that my denominator is 1 times 1 times 1 times 1. So that is just 1. So our result is actually just the value x minus 1, such that our domain is restricted from +1 and -1 and -4.